Good morning, all of you, and welcome in second year B.SC Physics. Today, we are going to introduce the syllabus of second year B.SC third semester, paper number 7, that is Mathematical, Statistical, Physics, and Relativity. This is the name of paper. In first year B.SC, we have studied a 6 number of papers. In that, a 4 theory paper and 2 practical papers we have already studied in first year B.SC up to the paper number 6. And in second year, we have to study paper number 7, that is a physics paper, that is theory papers are 2, that is paper number 7 and paper number 8 in the third semester. And after that we have some practical papers. But here we are going to introduce a very important chapter in that statistical physics and mathematical physics. That is, we have to study a 4 number of chapters. These chapters are very important for studying the physics. That's why here we have to introduce a chapter number 1, that is differentiation and ordinary differential equations. Differentiation and ordinary differential equation, this is a very important topic while studying the physics for degree level and also PG level. That's why we have to introduce this topic in this second year B.SC Physics. Also, in that course, we have to study 3 different number of sections. First one is we have mathematical physics. Second one is we have statistical mechanics. And third one is a relativity. These 3 sections we are going to study in this course. That's why this course is very important while studying in the second year B.SC Physics. In that we have one topic for mathematical physics and 2 topics for statistical mechanics. For statistical mechanics we have statistical basis and classical statics. And third one is a quantum statics. These 2 topics are comes in the statistical mechanics. And lastly, we have a theory of relativity. It is very familiar topic we have to study in this course. That's why we have a 4 number of topics, and in that first section we are going to start today first here, that is mathematical physics. In mathematical physics we have to study differentiation and ordinary differential equations. Syllabus we have to see from the syllabus books or university website. These are the 4 number of topics, and after that we have to continue here today's lecture. That is a first topic is a very important, that is topic number 1. Topic number 1, differentiation and ordinary differential equation. Ordinary differential equation. In this topic, first of all, we have to study about a first topic, that is limit of a function. First topic we have limit of a function. Basically, this is topic related to mathematics. In B.SC first year, we have studied about differential equation in mathematics. Here also we are going to study what are the application of differential equation in physics and what are the different types of differentiation. That is, in this topic, first of all, we have to study about a limit of a function, and after that we have a very important articles we are going to study. That is a partial differentiation, then successive differentiation, total differentiation. After that we have a exact differentiation. What is the condition for exact differential equation? And then 2 more important articles we are going to study: the first order differential equation and second order differential equation and its solutions. This syllabus we have to study in this topic. First of all, we have to consider here, that is limit of a function. In the limit of function, we have to consider the 2 variables, that is say x and y. In mathematics, we have to consider the variables x and y. In that, if we have x and y are the 2 variables such that x and y are the two variables such that we have to say that y is depends on x. Y is depends on x means what? We have to say that value of y is depends upon the value of x, and at that time we have to say that y is equals to say f of x means what? Y is equals to f of x. Y is depends on the value of x. If we are going to changing the value of x, what will happen that y is goes on changing. Means we have y is depends on x. Means we have what you have to say that y is equals to what? F of x. Y is equals to f of x. Suppose we have to consider that is y is said to be a function of x. Means we have y is said to be a function of x. If x and y are the two variables, किती variable आहेत? दोन variable. X and y are the two variable such that y is depends on x. If we are going to change the value of x, always y is goes on changing. Means we have y is equals to f of x is a function. Y is equals to f of x is a function. Y is equals to f of x is a function. Means we have y is a function of x. Y is a function of x. After that, we have to consider another function, say force. We have to consider say f. F is the force. Suppose f is the force, and we have to consider n number of variables such that n number of variables are what? That is f of x1, comma x2, comma x3 n number of variables. Means we have these are the independent variables. X1 is the first variable, x2 is the second variable, x3 is the third variable. These are the n number of variables. Means we have to say that a function f is equals to f of x1, x2, x3, and finally we have to say that function n independent variable, that is f is equals to f of x1, x2, x3 xn. And like next we have, suppose we have to consider function say f. F is a function of two variable. This is for n variable. For two variable, say x and y, what we have to say that? Therefore, f is equals to f of xy. Means function f is equals to f of xy. That is, we have to say that function f have a two independent variable, that is say x and y. Function f is equals to say f of xy. These are the two independent variable. Now, what is the article we have? Limit of function. What is the limit of function? If we have to consider the two variable x and y, these are the two variable, and for these two variable we have to consider y is depends on x. Means y is a function of x. Y is depends upon x means y is a function of x. And when we have to consider the n number of variable, what are the n number of variable? First one is x1, second one is x2, x3, x4, xn. When n number of independent variable we have to consider, at that time we have to say that function f is equals to f of x1, x2, x3, xn. And for two variable we have to consider, say x and y. These are also independent variable. X is the first independent variable, y is the another independent variable. Then we have to say that function f is equals to f of xy. This is called as what? A limit of function. And after that limit of function, we have to consider a partial differentiation. Right on this one, this is what? Limit of function. If x and y are the two variable, y depends upon the x, and then we have to say that y is a function of x. For any variable, this is the equation. For two variable, this one we have to consider f is equals to f of x, comma y. And after that, we have a partial differentiation. Write down. partial differentiation. Partial differentiation. In the partial differentiation, we have to consider what is the function. For function of the two variable, that is, we have to say that consider function f is equals to f of x comma y. This is the first equation. Here f is the function, and then what we have to consider, that is first of all we have to consider f is equals to f of x comma y. F is the function of x and y, and after that we have to consider here, that is x be the changes to x plus delta x and keeping y is a constant. If x changes to x plus delta x, x changes to x plus delta x, keeping y is a fixed or y is a constant. Then f changes to f plus delta f. Therefore, equation 1 becomes what we have? F can be changes to what? F plus delta f, and f of x can be changes to x plus delta x comma y. F of delta f and f of x plus delta x comma y. After that we have to say that this f is moves to the side. What you have to get, that delta f is equals to f of x plus delta x comma y. Here f is plus, in this side it becomes what? Minus. From equation 1, what is the value of f here? F is f of x comma y. Therefore, delta f is equals to f of x plus delta x comma y minus f of x comma y. This is say equation number 2. This is called as say equation number 2. Now divide both the sides by delta x and taking the limit as a delta x tends to 0. What will happen, that divide by delta x both side and taking limit delta x tends to 0. Therefore, that is delta f divided by, what you have to say, that delta x, delta f divided by delta x. Also we have to take what? Limit. It gets that limit as delta x tends to 0, that is delta f divided by delta x, and that is equals to limit as delta x tends to 0, f of x plus delta x comma y minus f of x comma y, this divided by delta x, this divided by delta x. Now the quantity, this is equation number say third. The quantity limit delta x tends to 0, delta f upon delta x. This quantity on the left hand side, the quantity delta limit as delta x tends to 0, delta f upon delta x is called a partial derivative of f with respect to x, is called partial derivative of f with respect to x. Partial derivative of f with respect to x. This is called as what? Partial derivative. And this can be denoted by this partial derivative limit as delta x tends to 0, delta f upon delta x, and is denoted by, it is denoted by say dou f upon dou x or dou f upon dou x keeping y constant, or it is called as f of x, fx. This is called as what? Fx. Simply we have to write this is the symbol fx. Fx. This is the way we have to denote a partial differentiation, that is dou f by dou x or dou f by dou x keeping y is a constant or f of x. Similarly, first of all we have to consider x changes to what? X plus delta x. When y changes to, similarly y changes to y plus delta y keeping x constant. Therefore we have to write that limit as delta y tends to 0, delta f upon delta y, and that is equals to limit as, that is equals to limit as delta y tends to 0, f of, now x is a constant and y changes to what? Y plus delta y minus f of x comma y, this divided by, here replace delta x by delta y, and this is equation number 4. These are the equation number say third and fourth we have to consider. And here the quantity, again we have to say that the quantity which quantity here? Limit h delta y tends to 0, delta f upon delta y is called partial derivative. Is called as partial derivative of f with respect to now what? Y, and it is denoted by, how it is? Dou f by dou y or dou f by dou y keeping x constant or it is also called as Fy. This is the denoted. We have to say that this is also called as what? Partial derivative. This is the partial derivative. This one is also a partial derivative we have to consider here. Now, the derivative of the function with respect to variable keeping other variables are constant is called as a partial derivative. Derivative of a function with respect to x or variable keeping and other variable is a constant is called partial derivative. And notations. What are the notations here? Notations we have to consider here. That is, first one, dou f by dou x keeping y constant. This is the first notation, and that is also is equals to what? F of x, or that is also equals to dou f by dou x keeping वन व्हेरिएबलच्या ऐवजी दोन व्हेरिएबल सुद्धा आपण काय करू शकतो? कॉन्स्टंट करू शकतो. दॅट इज y and z are constant. This is the notation for a partial derivative. After that, further partial derivatives are the function of independent variable, and hence they can be differentiated again to second and higher order derivatives. For second and higher order derivatives, for second and higher order derivatives, what we have to consider? The first of all, we have to say that f of we have to write here fx xx means what we have? Dou by dou x into dou f by dou x, and that is also equals to what? Dou square f upon dou x square. This is the first one. Alright, for second order and higher order. Now, f of yy is equals to what? Dou by dou y, dou f by dou y, and that is equals to dou square f upon dou y square. This is the second order differentiation we have to consider here. After that, for mixed derivatives, we have to consider the second one is what? fxy. fxy. For fxy, what we have to write that? First one is what? Dou by dou x into dou f by dou y, and that is equals to what we have? Dou square f upon dou x into dou y, right? Dou x into dou y. And thirdly, we have to write here f of yx, and that is equals to dou by dou y bracket मध्ये dou f by dou x, and that is equals to dou square f upon dou y dou x. Dou y dou x. This can be written as what we have to say that here. For first of all, we have to consider here y and x now. Sorry, this is y, because what we have to say that firstly this is second order is important here, x, and this can be, we have to write here dou y dou x. Here also x, here y, here x, dou x dou y. Means we have, see here, y is here, that's why we have to consider here. The first one is we have to consider that is dou y dou x, that is x y. That's why first one is x and then y. Then also here yx, first one is what? Y, and second one is x. This is finally we have to consider for the continuous function, that is, we have to write that f of xy is equals to f of yx. This is called as what? A partial derivatives. And after that, therefore, the continuous function we have to consider here. Function f is a first order partial derivative. Is a continuous. The order of differentiation is not important for the continuous function. That is f of xy is equals to f of yx. Question may be asked on this. What type of question may be asked? See here. First of all, we have to question may be asked on that. Write a short note on partial differentiation. This is one question. Secondly, by using partial differentiation, we have to write that